Fireside chat about Apache Mesos. This is the first fireside chat we do, and in case you're wondering why do you see the picture of fire, so at some point, I was going to a bunch of conferences which have fireside chats, and none of them had a fire. And I thought this is a legitimate reason to ask for your money back, right? Because you were promised a fireside chat and there is no fire. And so I tweeted about it at some point, and then I realized, I have to adhere to my own principle. So, you have to produce an appearance of the fire. So this is what we have. And
I expect a real fire next time, Alexa.
well, I did not say real fire, right? Like I didn't say organic fireside chat. So, and I know this, it's been a long day, and so we kind of had a happy hour. So we kind of are playing by ear, right? We're thinking that when we should do this. Some conferences do a talk during dinner, right? And it feels a bit awkward. And so it's an experiment for us. So bear with us. But I think it's really a great occasion. Right in the spirit of history, we have Ben Hindman, who is the creator of Apache Mesos and the initial team lead, and Ian Downs, who is the current team lead of Mesos. And so I'll tell you my brief kind of history. So I was a startup founder, and we did everything with Scala, and we basically asked Marius to mentor us. And so Marius was kind of explaining different things what the Twitter does. And then I heard about Mesos, and it was 2012. And to me, it all sounded magical, right? Because essentially, he described to me a magical world where machines are not your friends, where you don't know their names, that there is no DevOps essentially. DevOps is not giving IPs like names, and you magic, and so then you have this Scala job, and it lives in this magical package with a manifest, and you say what it should be doing, and it goes out there and it finds, like if it needs a service, it finds the service somewhere and it connects to it, right? And so I just thought this is most amazing. Why is Ben not going around talking about it, right? Because Marius was going around talking about Finagle, but Ben was basically, I think we, didn't see Ben talking about it, right? And so I think a few years later, Ben started talking about it. So I still remember how impressed I was about this idea. I think now much more people understand how this works. But again, right, we're at the kind of the cradle of all of this. So I just want to invite Ben and Ian to tell us a little bit more about how this whole thing started and how it evolved internally in Twitter and externally. So welcome, Ben, and welcome, Ian.
Awesome, great. Thanks for having us.
Thanks, yeah.
Where should we start?
Yeah, so maybe, Ben, you can tell us a little bit, kind of how it evolved, how Mesos evolved at Twitter during your tenure here. Where did you kind of hand it off to subsequent teams? And Ian, maybe you can pick up there and tell us how, where it is now, essentially.
Sure. So I guess it was early 2010 when we were first talking to a couple people. I guess we weren't really on the meetup scene when we were first talking about Mesos. But through UC Berkeley, which is where I was a PhD student, we were chatting with a handful of organizations about this thing we were building at Berkeley called Nexus. Actually, it wasn't even called Mesos at the time. It was called Nexus for doing cluster management. And I still remember the first talk I gave here at Twitter, not here, actually, a couple offices ago, I guess. Not even that building, or whichever building was the previous building. Anyway, and I remember I gave a presentation, and there was like 8 people, 8 engineers. This is totally before your time, man. But there was eight engineers in the room, and I remember being super bummed because we'd given a similar presentation at Google, and there'd been like 80 people to hear us talk. And there's like 8 people, and I was like, this is a waste of time. Why did we come to Twitter to talk? And then the chief scientist turned to me and goes like, oh, great turnout. You got 10% of the company. And I was like, whoa, yeah, that's crazy. So that was early days. Basically what happened was, for any of you that were at the panel earlier, Mark was talking about, there was sort of a lot of early Twitter engineers. I shouldn't even call them early Twitter engineers, because early Twitter engineers were like 2008. And then there was sort of this influx of Twitter engineers in like the late 09, early 10 and through, who who basically came from Google. And so a lot of them saw that, that they could get this thing that they'd had at Google called Borg. If they could use Mesos. They're like, oh wow, I could use Mesos to get Borg, and I had this wonderful cluster manager at Google called Borg, and I miss it desperately, and I need it. So there's a handful of engineers, some of them by name, folks like Bill Farner, John Sirois, Travis Crawford. Some of these, none of them I think are at Twitter anymore, although I think Bill is still doing some work with Twitter. And so they all said, wow, could we use this basically to kind of create a Borg? And that was early 2010. And then I started to come in and work with the chief scientist at the time, a guy named Abdur Chowdhury. We started to build out, it was Nexus, we soon called it Mesos, as well as some other things on top, a critical component called Aurora, which Aurora plus Mesos is what made Borg for Twitter. Let's see, what else is interesting from a history perspective. So that was 2010. The first service I think we ever ran on top was build service, which started with a T, I forget. It was not a bird name. Most services at Twitter are bird names. And this is like, he was like, no, it was the redirector, I think. Maybe Evan remembers. Anyway, that was one of the very first services to run on top. Then after that, we started to get a lot of services to move over. 2012, 2013, 2014 is when ultimately I moved on. We just founded a company, Mesosphere. I'm happy to talk about the times in between. But I don't know, maybe you want to pick it up from there.
Sure. So my time dates back to 2013. At Twitter, when I joined. If you go back a bit further than that, I was actually doing my PhD at Stanford, and
Go Bears.
Sorry?
Go Bears.
So ultimately, I dropped out of the PhD, but what I dropped out to do was to try and start a company. We looked around us when we were doing our PhD, my co-founder and I, and we saw lots of talented people who were trying to run their simulations on, at that point, we had our own clusters inside Stanford. They were trying to run these sort of large simulations. Most of them were Monte Carlo simulations, so they're pretty easy to parallelize. But they couldn't do it. They were struggling to even go beyond their one laptop. So we founded a company where we tried to make it really easy for them to scale out their applications and run them on something like their own sort of private cloud. Ultimately, coming straight out of academia, we had no clue what we were doing. We had no idea about what the market was. We tried to sell to academics, which don't want to pay for anything. And so ultimately we ended up at Twitter a few years later. So I joined in 2013. I have to say some of the things that we built in our prototype haven't even made it into production yet. Very valuable things, but for various reasons. So I joined in 2013, overlapped with Ben, I guess, for about a year or so. And then I was an IC for probably 2.5 years. The last 2 years, I've taken over management of this team, the Mesos team, also the Aurora team, and some other teams are related, kernel, JVM, and things that are sort of coming together. But I think it's changed a bit in the last few years, so we can talk about that.
Sure. Yeah. I mean, one of the things that I thought would be fun. I mean, so 2013, I can't actually remember when Docker was officially announced, but so for us, 2010, 2011, and then 2012, when we were really starting to scale containers and do a bunch of interesting things. So it was PreDocker. I still actually remember, were you here when Solomon came? Okay, also, all right. Yeah, I mean, so we were using containers. The journey for us actually was we started with LXC. Does anybody remember LXC? Yes, we started with LXC. It was really interesting because we ended up moving away from LXC because we decided it was a dying project because there wasn't a lot of contributions to it. Again, this was pre-Docker. We ended up using control groups and namespaces ourselves. At Twitter, there was a project that got kicked off called AppApp. Do you remember AppApp? So there's this project called AppApp that got created, and AppApp, I think it stood for the application for bundling your application or building your application to AppApp. And the way it worked is you typed AppApp, I think create, enter, and then it dropped you into a shell, and then you'd like yum, install or, pull down some zips or whatever you wanted to. You'd install some stuff, and then you'd Control D, and it would pop you out, and it would give you a zip file. And that was a zip file that the plan was is that people would use that to run on top of Mesos. Because in the early days, we didn't have Docker, and so people were they were basically just sending us tarballs or zips or static binaries or any of that. And so we'd create this thing called app, and the security team at Twitter, if I remember, pretty much said like, nope, we're not going to invest in this. There's no way we're going to let engineers put arbitrary things inside of these zip files. And we were like, well, they can already do that. And but this makes it even easier. And so it got totally canned. And then I remember probably maybe 8 to 12 months after that, we got this email from these folks at .cloud. And they're like, hey, we're working on this thing called Docker. We'd love to show it to you since you guys are doing containers at scale. And they came over, they did this like round table, they showed us Docker, and we're like, oh, that's super cool, but it's never gonna work because security organizations at companies are never gonna support people to put arbitrary things inside of your containers. So we're not interested. And I think to this day, there's still no.
Yeah, so we sort of depart from the rest of the community. We still don't use Docker. We still don't use file system images for our containers. We still force our users to bundle everything with their application, and they still run on the host file system, which is pretty different to, I think, most other users.
Yeah, I'd say so.
We've actually investigated at various times moving towards either Docker images, not necessarily Docker itself, but the Docker image format or the AppC image format. And to be honest, it hasn't been a priority for us, partly because everything we do inside the company is on the JVM, so people just deploy jars, which deals with most of the dependency issues. And then the pain of being coupled to the host file system hasn't been enough for us to invest effort in moving away from this idea.
So, Mike, because, it's late, we have beer, so can I ask like a blasphemous question? Can I be a devil's advocate, right? And I mean, can I admit that like I hate containers? Like why? Why do we need containers? When I heard this first, good news about Aurora, right? And the manifest and the Scala job inside of it, right? So in the ideal world, everything is in Scala. So why do you need an OS? Like you need JVM, right? Why do you need all this craft around it? So you have your program, right? And you have some metadata which tells it where to find other programs. So there's a service discovery. Everything is in Scala, right? And so as an application software engineer, you don't really need. Why do you need an OS? It's basically, to me, it sounds like this, the new generation asking, what is this floppy disk icon in the email or app or Word? Like, I don't know what it does, right? So I did my own share of compiling Linux kernel many times, right? And so we have now this atavistic image of an ancient machine, it kind of immortalized in a virtual artifact, right? And we're kind of moving it around with all the extra stuff, although you know that, for Twitter stuff, Aurora is totally fine and it's not doing this, right? So why can't this truth be seen by the outside world? Why, people who already have Mesos, why do they feel like they need containers?
Should I start? Sure. I will say this. I think one of the biggest questions I ever got once I first started talking to people about Mesos, the biggest question I ever got, and I got it in all sorts of different ways, was how do I get my stuff to the machine? And I remember the first time I got that question, I was shocked. I was like, what are you talking about? We'll send the task to the machine. We'll start the task run and everything. And I go, no, but how do I get my stuff to the machine? And I was like, what do you mean? And like, well, I've got this thing installed at this place, and I've got this thing set up this way, and I've got this one configuration file that I put at this path and all this stuff. And I think, Alexei, maybe the answer to your question is because a lot of software is still built in this model where this expectation of the way that we're going to install our software and run our software and configure our software, and call it legacy, but it's the way a lot of people actually end up doing stuff. And to me, the container actually just basically makes that a lot easier. So if an organization is willing to go through the, I'll call it burden, but perhaps it's just an initial burden, and eventually it's like
It's constant pain.
Is it constant pain?
Yeah, so one of the biggest requests for us is when will we support Docker? And the thing that I ask is, why do you want Docker? And they say, I want to pull down some image from the web, which doesn't go down well with security, of course. So they're looking for flexibility. They're looking to bundle up things. They're looking to have the latest version and whatever else. But when you sort of peel that back, if the organization does make that effort to support something and to guide everyone towards the same platform or the same language, whatever, it does give you a lot of advantages, which really mean that you don't need containerization to the same extent that others do.
Yeah, I mean, I think if a company just chooses to go through the arduous task of deciding that they're going to create the infrastructure so you can just be on the JVM and have everything you need and make that super easy, then I think the need for containers goes away. But the problem is there's just a lot of software out there that is not like that. And like, think about the number of new projects at each company every day that's trying to take advantage of other tech. They're constantly just want to install it the way that they've installed it for a really long time. And that's the container.
This is recorded, right? Yeah. So I think for us, historically, we've developed a lot of software internally to Twitter, which made sense to run it on the JVM. I think looking forward, we will be adopting a lot more open source, in which case we don't necessarily control which language they're written in.
Totally.
So for us, on our roadmap is to adopt something like Docker images, so we can do this sort of thing. It just hasn't been prioritized yet.
Yeah, and the other aspect that I would throw in about that is I still think there's a lot of organizations that are not really, like, even if it makes sense to bring in Docker containers, I still think there's a lot of hygiene that you could really exercise with containers. And that to me is one of the most interesting things, is when I go to a lot of organizations who basically are treating containers like giant VMs. Mm-hmm. And they'll ask us, they'll be frustrated because they'll say, well, we moved to this platform so we could launch our apps in microseconds, because that's what you guys promised. And then you dig down and it's because they're downloading like a 2.3 gigabyte container. Mm-hmm. And that's obviously, we're not going to launch that thing in microseconds. So I don't know if containers will go away. I know that Mark expressed that earlier, that we'll move from containers to serverless to functionless, which I really liked that. I hadn't heard that one before. That was good. I'm not so sure that we'll do that, at least not super fast, but maybe perhaps we'll just get better hygiene within the industry of exactly how we're using containers. And
yeah, I mean, I think I understand, right, on the rational level, but to me, I've been exposed to the higher truth, right, of Aurora, and so that kind of brings me to another question. So when I heard about Aurora, I thought, like, this is exactly what, in the ideal Scala world people need, right? Because if you're a Scala developer, you don't want to interact with DevOps people. You don't want to beg them for anything, including names of servers, of things, right? So essentially, basically, there is this magical world where you dispatch jobs on a cluster. They're barely more than a Scala job, right? So basically, you wrap it in a thin layer, and they know what other things are. And so then Mari described how this is useful, because if you debug your own service, like search, right, you can mark the packets as being kind of your own, and then you can dispatch them differently. Right? So to me, that was exactly all that was needed to develop a web scale company such as Twitter. So when I've seen Mesosphere take off, right, I was actually very curious, right, how this is going to pan out, because what this intellectual treasure encased in Aurora, I thought, like, it should come out, right? But what we've seen is basically Mesosphere took up Marathon, because I think they initially compared it to Rails versus Spring, right? It's like a Marathon is basically the Rails of compared to Aurora, which is Spring, and Aurora was not open source. So I want to ask Ian, what is the plan? I mean, Aurora is still, right, contains all of this knowledge. How you guys are going to bring this to the world, especially since Mesosphere is not really using Aurora itself, right, and bring it to its customers?
I'm not sure why that's my question and why it's not Ben's question. So Aurora is open sourced. It's got a number of active users in companies, There hasn't been the same level of investment in making it easy to use and easy to sort of take on board. It's got a lot of dependencies, Zookeeper, and a bunch of other stuff. Really, it's a question of resources for us. We haven't got the time to sort of clean that up and make it useful to others. I wish more people saw the benefits or would see the benefits of Aurora. It's harder to use. It's harder to. It makes the difficult problems easier, and it makes the simple problems a little bit harder. So I think it gives that sort of hurdle. But really, at sort of large scale, I think it is what I think is the best scheduler that's out there. I'm biased, but.
I mean, so ultimately, I think from the Mesosphere perspective, we're very happy when organizations have something like, if they want to run Aurora, we're happy if they want to run other things as well. As I sort of mentioned in the panel earlier, one of our investments initially in Marathon was because of some of the delay in Aurora open sourcing, which was unfortunate. But so creating open source communities is exceptionally difficult. And I don't think people fully realize, I don't know if everyone fully realizes that it's a lot of work. It's a lot of time and energy that you put into supporting people in the open source. And I think my guess is that's probably one of the things that has made it more difficult for Aurora as well, is you just need full-time people all the time trying to foster open source communities, run events. It's a ton of work. And I think everyone wants to hack on open source. But it's just a tremendous amount of work. So even once Aurora was open sourced, I think our perspective was, let's continue to build out a bunch of open source projects and see where it goes. And I think Marathon had a lot of open source adopters pretty quickly, and a lot more people were using it. And so we continued to invest a lot in there.
Okay, yeah, makes sense. I mean, it still would be interesting, right, to see that kind of a path, right, for organizations. And I guess I think there is this very interesting multi-level complexity, right? Because on the one hand, you have open source Apache Mesos. On the other hand, you have DCOS, which is right? But a lot of organizations are still adopting pure Apache Mesos, right? And then you have schedulers. So I don't know if everybody knows the difference. Maybe you guys can quickly explain, right? But we have this multiple levels. So Mesos can take either Marathon or Aurora, right? And in DCOS is something. So maybe you guys can explain how these three levels interact.
So we don't use DCOS at all. I have very little knowledge about that. I'll defer that to Ben. For us. To be completely candid, I think the Aurora Mesos split early on reflected the sort of teams that were inside Twitter. I think we had separate teams doing this. I think Mesos came along, Aurora came along, was a separate team. So the sort of architecture somewhat reflects the social structure that we had. Now, though, we see Mesos as being really an abstraction for us on the cluster. We don't run multiple schedulers on our clusters. We only have one Aurora scheduler on the whole cluster. So we don't utilize a lot of the functionality inside Mesos that's around multiple schedulers. I think that's one sort of key difference with the way that it's used by others. Do you want to elaborate more on that into service?
Sure, yeah. I mean, so the architecture of Mesos is to exactly support multiple schedulers. So we kind of call it two-level in the Mesos world, which is to say that there's the first level of scheduling, which is Mesos, and it's not even really scheduling, it's more resource allocation. It's like the I don't know what the right term is, but it's the really basic, how many resources should this thing get? How many resources should that thing get? How many resources should that thing get? Not, given those resources that are available, what tasks should run on which of those resources? And that was a really it was an important architectural difference. I mean, when we first created Mesos, getting back to the Berkeley days, cluster management was not a new topic. I mean, anybody ever heard of Condor? Yeah, all right. So, Condor is a pretty sophisticated resource manager that was used in a lot of organizations, especially financial organizations. Condor was pretty simple. You described your declarative specification. you gave that declarative specification to Condor, then Condor used that to decide how it actually wanted to schedule things. So what we were really trying to do with Mesos was say that we believed that there needed to be a split between, I don't know what you call it, the business logic of deciding where you want to run stuff and just the platform, the foundation managing resource allocation and everything else. And like that really was a core part of the innovation, if you will, in Mesos. And some people, they've even asked me, like, because there's been a lot of other cluster managers that have, or resource managers have been created since, right? There's Docker Swarm, there's Kubernetes, and there's Nomad. I think in that order is the three that got created. And people have asked me, well, would you have created Mesos again if these three things have existed? And the answer would be yes, exactly, because architecturally, we took a very particular perspective of how we wanted to build Mesos, which was we wanted to split these two levels. We wanted to create this two-level system. Whereas a lot of the other ones that have been built, they follow very much the Condor declarative specification pattern. And to be very clear, I don't think that that's a bad pattern. I think there's a lot of organizations that want to take advantage of that pattern. There's a lot of people that want to take advantage of that pattern, but not everybody. And we wanted to be able to provide a platform where people could do other things. And you start to see on some of these other platforms, people want to actually take advantage of this two-level pattern. So you start to see it in the Kubernetes world where they're trying to create what they call operators, which I love that name. I wish we would have thought of that name for our second-level things instead of schedulers, because you say the word scheduler and like you scare everybody away. They're like, oh, I don't have a PhD, I can't write a scheduler. Oh, that's like a academic thing, I can't work on that. Whereas operator sounds like way less crazy. But then when you look at how you're trying to like build those things in, and there's like gotchas architecturally to how you'd want to do that in a system where fundamentally you're still in a world of writing a declarative specification and submitting that declarative specification. So yeah, I mean, that was a big part of the way we built Mesos. In the early days of Twitter, that was like really new. That was like too new. Like when we talk to a lot of the folks at Twitter, they're like, what? That's crazy. Like it's crazy enough that you want to move us to a world where we're going to go from running Puppet on boxes to putting stuff in zip files to running in containers. And the two-level stuff was even more new. But now it's like, it's a critical part of what we do inside of DCOS. It's really, really important for everybody that we work with. Fundamentally, we're running Cassandras and Kafkas and Sparks and Elastics and all these things, and they are all second-level schedulers. And we can run many of them, and so it's a really, really big part of what we do. And going forward, I think for the industry, I think it'll continue to be a really, really critical thing. A comment that was made earlier that I thought was really interesting was, Evan said the cloud is kind of like the killer of all these open source projects. And I think the fundamental reason for that is because nobody actually wants to operate this stuff. It's like too complicated to operate. So they want to use like an open source key value store, but they don't want to have to like set it up and manage it and operate it. And even like writing a bunch of declarative specs for this stuff and running it on a Kubernetes or running it on Aurora is still way too complicated. There's like still way too much stuff that you actually need to manage yourself. So I think we'll actually push farther and farther in the direction of these things becoming more and more managed services, which is again, what we're trying to focus on with the project and what we're doing. There was one more thing that I was going to say, but I totally forgot because I'm a lightweight. But yeah, I guess I'll leave it at that. What was the original question? No, I'm just kidding.
Yeah, maybe my stack is not as deep as yours. No, this is great. So actually, this brings me to this question we didn't ask in the architecture panel, but I think this is very interesting. It almost sounds like Mesos and other schedules are the last bulwark of freedom against the faceless giant cloud, right? Because the question, for SMAC stacks and other stacks, does anybody need them if you have BigQuery, right? Like you drop everything into giant Google cloud, and then you essentially, then you become serverless, right? So, but I mean, somebody still needs to run all of this, but suddenly the group of people who can run these things becomes very small, right? And so the question really is, right, like if we go to this model, it will be Azure, Google Cloud, and Amazon, and maybe, Tencent, right? And the question is now, if this knowledge of managing complex workflows is concentrated in very few hands, and then further and further removed from kind of general public, how does it connect to open source? How does it become accessible, right? So I'm curious, obviously you guys at Mesosphere at least should see it as a challenge, right? So what are your thoughts in general? Who are the customers who would need to run Mesos, right? And do you think, like in the long evolution, what are your kind of estimate how this is going to pan out against, the giant clouds?
Well, yeah. So, and I remember what I was going to say in the last one too. Thanks for reminding me. Well, so because you just said who are the customers that are going to run Mesos. So most of the organizations that we work with at Mesosphere, it's all about DCOS, and the reason why it's all about DCOS, which is what I was going to say at the end of the last question, is for the same reason that most of you guys probably don't go to kernel.org to get Linux. Some of you might, but it's dubious. You go get CentOS, or you get Debian, or you get something else. You get something prepackaged. So in the same way that you could have gone to kernel.org and you could have decided, I'm not going to use Bash, I'm going to use a different shell, or I'm not going to use KDE, I'm going to use, I don't even know what else people are using for Linux desktops. Right? You pick something that has a little bit more of an opinion. You could swap it out if you want. You could totally grab Ubuntu and then decide, I'm going to make my default shell as eShell or something else. You can do that, but like there's some prepackaged thing. So that for us is what DCOS is. And it's meant to just be that consumption that makes it easier for people to get things. So to continue then for your question, most of the local organizations that we work with is DCOS. So who are the companies that want this stuff? A lot of the companies are folks that actually don't want to just be in the cloud, or they know they want to be in multiple clouds. So if they don't want to just be in the cloud, they need something in their own private data centers to run that gives them a cloud-like experience, but maybe without VMs, or it's not OpenStack. Especially when it comes to a bunch of these other services, the Sparks and the Cassandras and the other stuff from SMAC, and that's a big focus of ours. We keep thinking about other things we want to run. So, like recently, we added TensorFlow to the mix, which is another thing that you can deploy and get a distributed TensorFlow pretty easy. So I know that's the big focus. I think. But I do think what's really interesting is cloud is like one of these really things. It's a huge enabler for so many organizations, and it's also a huge killer for a lot of open source projects. There's a bunch of clouds out there, without naming any names, that are huge consumers of open source projects, but never contribute back to those open source projects. And some of those companies then really struggle. But the part that's tough about all of it is like we still all benefit, because we get message queues by like clicking a button, or we get analytics infrastructure by clicking a button and having it get spun up. So it's tough, right? We're all benefiting because we can move faster in these environments, but it's a little gloomy for a lot of these open source projects. So we like to think about it as if we could be a way for open source projects to shine no matter what cloud you're on top of DCOS, then that would be a good thing, right? If we can make Kafka run on top of DCOS, and then you run DCOS at each of the clouds as well as on-prem, people get to get Kafka, the Kafka project gets to continue to blossom, and the company behind the Kafka project can probably continue to push that, and everybody wins. And then the clouds still win too, because they're getting paid because you're getting VMs run. Yeah, that's it.
Yeah, there was, actually, it makes me think, right? If this company, which we're not going to name, is not contributing back, but using all this open source stuff, who's going to maintain the individual components? There should be an economic model by which they will do some rev share with the original project.
Yeah, I was having a good conversation with somebody about this the other day, that there should be a new license. So there's like Apache, right? Which is just anybody can take it. There's a GPL, where if you start using it, and then obviously there should be another license, which is what have you contributed back, right? You want to use the code, you can totally use it, but how have you contributed back? There's many ways you can contribute back. You could write a $500,000 check a year to run amazing conferences for the open source project to support open source developers. And that's one way in which an organization can contribute, but in some way you're contributing to the open source project, and so you get to use the license.
That makes sense.
Yeah.
So, Ian, I have a question for you, right? So, I know that you guys did a lot of stuff, resource utilization, and that kind of brings me back to the history of, Mesosphere. So, when Mesosphere appeared, right, my immediate thought was, finally, we have a fantastic platform for the Smack Stack, which, at the time was not the Smack Stack, but basically my immediate thought was, this is going to be the Aurora enabler for the masses, right? So, what I described as the Scala world, but instead, what I heard was, hey, data center managers, we can utilize your machines to the hill. So the initial selling was basically kind of pedestrian, right? Like, let's utilize the crap out of this, right? Like, you paid for the machines, you pay for the electricity, let's make sure that all this stuff gets utilized. So that was the initial push. And so when I was talking to Flo and Toby, I was kind of pushing for the big data agenda. And so now it caught on. And so I see now the Smack Stack being part of the story for Mesosphere, which I'm super happy about. But so I'm kind of curious. So in Mesosphere, it seems that this dilemma or kind of duality, resource management versus pipeline enablement, right? It went finally kind of to pipelines. But it sounds like at Twitter, you're mostly focused on resource utilization. Can you talk about these two heads of Mesos?
Yeah, so the workloads that we run is sort of mostly just all of the other stateless services. So state being somewhere else, not that they don't have any state. We don't run a lot of, I'm not even sure what the Smack Stack is. Can you fill me in? This is
Spark, Mesos, Daka, Cassandra, Kafka.
Okay, yeah, so we don't run much of that. That's all up on somewhere else, on some other clusters. We'd like to run those on the clusters. I think what you're asking about is the resource utilization of our existing clusters. Yep. Yeah, so for us, Mesos has been pretty instrumental as core density has gone up. We've got services inside the data center that run on a single machine. And so that's okay if you're running on a quad-core machine, but now you can't really buy a quad-core machine. Now we're buying 64-thread machines, whatever else. So being able to take that service, containerize it, put it on, and run it somewhere in our platform, taking up only the necessary resources that it requires, that is what is pretty instrumental to us in achieving a high reservation. So I'm hesitant to call it actually utilization, because we do attribute all of the threads on the box to a particular container, but that doesn't necessarily mean that we have high utilization of the box itself. That's a separate question, I think. I can talk about that. Yeah. So for us, for stateless services, most of ours are actually latency sensitive. So we're fairly conservative in how aggressively we pack stuff onto our machines. But it's really an area for us where we have clusters with many cores in the cluster. How do we increase the utilization overall of that cluster? Because even 5% increase in utilization translates into a lot of dollars for us. So there, it's pretty important. And we've found that, and this is through no fault of, this is not at the Mesos level, this is at the individual schedule level. Our sort of experience is that the Linux kernel in its stock configuration is not great for high utilization workloads that are also latency sensitive. So a big area of work for us is how do we improve the resource isolation, targeting good predictability, low variance in performance for the containers, but also being able to trade off between different workloads running on the same host, and overall increasing utilization of the cluster. I don't know how much of a concern that is for other customers who are operating at smaller scales, but for us, it's one of our leading concerns going forward.
Yeah, I wouldn't even say smaller scales. I would just say earlier in the process. You asked about patterns in the last panel, and a lot of organizations that are first doing this transformation in their companies, it's just so early. It's so much earlier. Whereas Twitter, I think, is at a place where they can actually be doing a lot of interesting stuff because they've just got the platform there.
Mm-hmm. So do you guys at Mesosphere, do you now kind of look at Twitter as the cradle of innovation, right? Is there like flow going back from Twitter to Mesosphere?
For certain things. If you look at the talks at MesosCon that Twitter are giving, there are always things that other customers of ours are always like, oh, well, we want to get that thing as well. But we're sort of like, well, you're kind of a ways from there. You got to get your cluster stood up first, and some of the other stuff. Yeah.
Thanks. And one thing I learned recently, and I can say this because I'm not Mesosphere or Twitter. That I like Apple and Uber are running huge Mesos clusters. And the question is, who has the biggest Mesos cluster in the world? And the question was very interesting to me that it's not even an open, like it's not a solved question, right? Like it's still, we don't know if Apple runs a bigger cluster than Twitter, or I mean, at least I don't know this. And so to me, it's very encouraging, right? Like I think it's a very good sign that these, kinds of companies selected Mesos. And I didn't know actually this until I knew that Apple is a huge user of Scala, and Apple is a substantial participant in this conference, right? So I kind of learned that they run one of the biggest Mesos clusters after they join this conference in force, right? So to me, it's very encouraging. So maybe, like it's getting a bit late, so maybe we can wrap up the first chat with the question, where do you guys see Mesos going inside Twitter and outside? Like what are your plans and how you guys are going to collaborate maybe kind of going forward?
So right now we're running all the stateless workloads. What our sort of goal for our team is to be the single infrastructure layer across all of our hardware. So running all of our services on top of Mesos. Not just stateless, but also all of our stateful workloads, all of the backing stores, even going as far as Hadoop and everything else. We want to sort of basically run everything on top of us. And that is less to do with resource utilization for those other services, more to do with, I think to your earlier point, people are really sick and tired of managing hardware, and they want to get out of that business completely. They want to think about, this is my service, these are the resources that I need, go run it for me, and just keep it running. So we want to offer that for the entire company, for all services that we need to support. And we work closely with sort of Mesosphere folks to be able to do that. They're really pushing the envelope in terms of stateful frameworks. We'd like to adopt some of those ideas into Aurora and take advantage of the work that's been done in Mesos that actually enables all of that.
Yeah, and I mean, as you were talking about scale, at Twitter scale, and some of the other companies you were talking about at their scale, we learn a tremendous amount about what we need to do to improve the project and improve the product. We have I think if you just take those three companies you mentioned, and maybe you throw one more in there, which is Netflix, that's a lot of containers that is running on top of Mesos. We learn a lot from people doing that. I mean, I don't know if there's any Mesos users in the audience. All right, sweet, great. Well, so when you get to a certain scale, like there's just certain things not to do, like hit /state, which is an endpoint.
We have some users, some of our customers inside the company decide they want to hit state.json, and it's not pretty.
It's really bad. Like at the scale of some of these customers, it's like takes like minutes to actually do that, and it like completely blocks the master. It's like crazy. So it's we're working on a fix for that though. Yeah, really good.
We've just to give one other sort of issue. A while back, we reached a certain scale point where, on a master failover, when all of the agents who were listening to Zookeeper, when they tried to reconnect, the master actually determined that it was a SYN flood attack because there were so many incoming TCP connections at basically the same time. At which point most of those were denied and dropped and everything else. And of course they would try to reconnect again, and it would just keep flooding, and eventually take down the master. It would fail over, and this would continue.
That's a big cluster.
Yeah, but we contributed some fixes back, and things are fine now.
Yeah, so that's a big part where we still partner with a lot of open source folks, and that helps make the tech even better. And then people who end up adopting, and as they grow themselves, as they scale themselves, they get to benefit from that work being done because we've got some really big large scale users. So that's how we'll keep collaborating with folks like Ian. I think we have lunch scheduled soon, right?
Within 2 weeks, you said.
Yeah.
All right, guys, I think this was great. One thing I learned personally, in my mind, if I replace scheduler with operator, I feel so much happier now. So I'm going to do this from now on. It's better late than never, right? Let's just all start doing this, right? We'll all feel better. It will all become clearer. So it's operator, right? It's not scheduler. So thanks a lot for you guys. This has been a long day. You guys are the veterans. And, I learned that Raleigh is using Mesos. This is great. Raleigh is a sponsor. So this is awesome. Really appreciate it. Thanks, Ben and Ian, for staying with us. Let's give them a huge round of applause. And we have this space.